Greetings, everyone. I just want to have a brief discussion with you about rates. Okay, rates are different than what we were dealing with ratios. Rates have a unit. Okay, it is important that we know this, and it's usually specified. Okay, when you think back to ratios, we didn't care what the units were. I mean, we could have apples to oranges, and that's fine. Okay, we're going to have a quotient of two quantities with two units. Quotient, so quotient means division problem, the answer to a division problem. We're going to have two quantities, so quantities let me know that I have two numbers, and I'm going to have two different units. So rates that we're used to dealing with would be something like miles per, and per is going to be my division sign, and then hour. Or maybe I get so many dollars per week. Okay, can you think of another rate? Maybe we have cost per gallon. Okay, so you can see here I have two quantities, I have two different units which make up my specified unit that I'm dealing with for my rate. Okay, so now what we want to do is we want to combine rates together. And the typical problem you see is like if I can paint a house in this long and you can paint a house in this long, how long does it take us to do it together? Okay, so we're going to do an example like that. These are very contrived, they're very frustrating. I always just want to say, just go paint the house, okay? Don't think so hard, just paint the house. Because what happens if we run out of paint, or it rains, or there's all kinds of things going on in real life. But these rate problems are important because we do deal with rates. We drive, we fill things up with water, and rates, the idea of rates is really critical for algebra, for dealing with slopes, and then again for calculus. Rates of change is just huge. So let's look at a specific example. Let's say that it takes Linus 6 hours to mow the lawn. Okay, so he's going to take one lawn. It's going to take him 6 hours to mow it because he has a push mower. Lucy has going to mow the same lawn, so maybe they alternate weeks. But Lucy gets to drive the riding mower, and so it only takes her 3 hours. So on her week, it only takes 3 hours. Linus's week takes 6 hours. So we're thinking about, well, what if they decide to finally work together? How long is it going to take them to do the job together? Well, let's think about this as a rate problem, okay? So the job for us is one lawn. So I'm going to say one lawn. And the time it takes each person to do it is different. So if it takes Linus 6 hours, what is his rate? Well, he does one lawn every 6 hours. So that would be 1/6 of a lawn per hour. Okay, that makes sense. If it takes 6 hours to do one lawn, he can do 1/6 of a lawn per hour. Okay, now over here we have Lucy. Lucy can do the same job. The jobs are the same. It takes her 3 hours because she's on the riding mower. So how long does it take her to do it? Or her rate is 1/3 of a lawn per hour. Now I want to stop right here for a second, okay, before I go any farther. If I had asked you at the beginning, just to take a guess, how long does it take them to work together? So time when they are working together. Okay, so does 9 hours make sense? Does it take them longer to mow the lawn when they're working together than it does each of them separately? Hopefully not. Okay, how about 6 plus 3? How about 9 divided by 2? Like I take the average. Does that make sense? So working together, it still takes longer than it does Lucy by herself? Well, that can't be possible either. So I know my answer has to be somehow less than 3. So because he's just mowing lawn. We're mowing more lawn at a faster rate. Our rate is faster. So if I take Linus's rate, which is 1/6 of a lawn per hour, plus Lucy's rate, which is 1/3 of a lawn per hour, that's going to be their time together. Okay, their rate together. So this is 1 lawn per hour, 1/6 of a lawn per hour, plus 1/3 of a lawn per hour. Oops, that should be lawn per hour. And so I can figure out their total together. Well, I want to get a common denominator. So I get 1/6 plus 2/6, which equals 3/6. Sorry about that. So what is this unit? This means it takes 3 lawns. I can do 3 lawns every 6 hours. Now, we don't usually think about lawns per hour. We think about hours per lawn. So I can say 6 hours for 3 lawns. So that means it would take 2 hours per lawn. So if they work together, it takes them 2 hours to mow the lawn. Okay? So that's cool because I combine their rates and I'm much faster working together than we are working independently. All right, we could solve this algebraically. We could say, well, I've got 1/6 times the total plus 1/3 times the total equals 1. So this is the rate times how long he works, rate times how long she works to get the entire lawn done. So again, we get a common denominator. 1/6 plus 1/3 is still 3/6x. Now we learned from fractions that we can multiply by the reciprocal. So on the left side, 6/3 times 3/6 is 1. And on the right side, I get 6 divided by 3, which is 2. And that tells me 2 hours. It takes 2 hours to complete the lawn. So this is like a distance equals rate times time problem. 1/6 of a lawn per hour times the number of hours gives me the amount I get done. Okay, so there is a formula that we can use. Okay, we're not going to look into that formula right now. We're just going to think about this process of combining our rates together. So I like this. Okay, I like this idea of setting it up in a table, and then I add these 2 lawns, or their 2 rates, and I get their ability, or their rate working together, and then I can figure out the time by taking the reciprocal of that. Okay, now use this idea to answer the video questions.